Awesome. Here we go. Good afternoon, everybody. My name is Sudha Anand. I'm the Digital Collections Librarian at Indiana University. Today, me and my colleague Julie Hardesty will be sharing about a complex migration project that we recently worked on. Before we begin, we wish to acknowledge and honor the Miami, Delaware, Potawatomi, and Shawnee people on whose ancestral homelands and resources Indiana University Bloomington is built. Indiana University has been focused on migrating image and document-based contents from its large inventory of legacy systems into its Hyrax-based digital collections repository for the past few years. Most of these legacy systems were housed on earlier versions of Fedora and highly customized delivery systems and interfaces. They also were able to support rich and sometimes messy metadata. These older systems lacked the ability to search within documents and images, and also did not meet the accessibility requirements we needed to meet the ADA Title II guidelines. IU's Digital Collections was designed to serve as an institution-wide repository for 2D and document-based archival material that supports high level of interoperability through the IIIF viewer while also meeting accessibility requirements. These are some rough numbers as they're constantly growing with both migrated content as well as new content being added to the repository every day. IU's digital collection platform is based on an implementation of Samvera Hyrax. This slide lists the key working parts of the infrastructure. We are still on an older version of Hyrax, version 2.9.6, with a Fedora 4 backend. We recently updated to Bulkrax 5 and Solar 9. We utilize a flexible metadata model through Allenson Flex, which helps us offer customized metadata field sets through context and admin sets. Recently, since mid-2025, we have adopted a Hyrax role group-based permissions management to administer collection manager and student employees access to admin sets and collections. Even though Hyrax supports derivative processing, to reduce overhead, we externally process files using a locally developed process called ImageProc. This processing results in a set of 3 derivative files for each original file: a pyramidal TIFF, PTIFF derivative, an OCR file, and a FITS characterization file. The process also QCs the file naming and verifies if it meets predetermined preservation standards. Finally, all original files are routed to tape storage for preservation. All content ingested into digital collections is preserved through tape storage. This presentation is about migrating the Cherry Slocum Puzzle Collection, which is one of our 3 largest collections from our Image Collections Online legacy system containing more than 37,000 works. The collection also had more than 140 descriptive and functional metadata fields, and several of the fields were not consistently used. The collection also followed an unusual naming convention and did not really have a clear way of grouping files belonging to each work record. Apart from the fact that it was a large collection, the biggest hurdle we faced was the metadata complexity of the collection. The collection had more than 140 descriptive and functional metadata fields that had to be accommodated within the 40+ fields in digital collections. In addition, there were also several private fields whose only viable option in digital collections was the internal notes fields. I will now hand it off to Julie to explain our process in detail.
Hi, everybody. So to ensure that we could preserve the rich archival metadata that they were coming from the legacy system with, in addition to offering a user-friendly digital object record, we ended up spreading this metadata out between 2 different repository services that we have. So Archive-based was used to create accession records, and then we also had information that was put into digital collections for each work. The archive-based records were preservation focused, and they are hosting details such as the donor information, appraisal value, price, things like that that end users aren't really going to be able to do much with when they're searching and trying to discover or when they're looking at a work. And on the other side, in digital collections, those records were dedicated to highlighting the digital object with pertinent information for search and discovery, such as the puzzle category, manufacturer, designer, the instructions for solving the puzzle, that sort of thing. And there were some fields that we ended up including in both systems, so like title, puzzle description, acquisition number, identifier, that sort of information. We also ended up having to make some hard decisions to actually not migrate some of the fields from the legacy system since they did not add to the value or were duplicated in the other fields that already existed. So this metadata division between the repositories was a really intensive process and ended up requiring a lot of consultation with the collection manager and understanding the collection manager's workflow to identify the best metadata solution for that collection migration in particular. We also discovered several fields with drop downs in the legacy system that had codes behind them, which were connected to local vocabularies, local controlled lists. And we also had to take that into account when we were doing this migration to get the right value in place. And the overall goal was to create a delivery system that was appropriate for the user experience. So next slide, please, Sudha.
Got it.
Thank you. So here is a quick look at how we did the metadata field split between the two repositories. And this is basically the same spreadsheet, just showing two screenshots to give more examples, more example rows. So Bree McLaughlin, who's the service manager for our IU instance of Archive-based, did the major work in establishing which legacy metadata fields could fit into accession records in that software, so the collection manager could still have full access to all of that information. And we use this spreadsheet here, this listing, as a way to identify the fields for each repository. So digital collections is shown in the first column and the fields that we wanted to bring in. And then archive-based is shown in the next column over, as well as those fields that we needed to have in both systems. So that's kind of that middle column that's showing both digital collections and archive-based using them. And in some fields that could be left out as they were only required for curatorial value and could be documented elsewhere. So over to the right in each screenshot, you could see there were actually several fields that we were looking at that were things we did not need to keep in either system. So next slide, please. So now that we had a smaller set of metadata, we went from 140 plus fields down to 42 fields. Suda was able to map those fields to the digital collections metadata fields through our regular migration workflow. So all the fields that needed to be private, but with the digital collections work record, there was still some information that needed to be there in the digital collections work record for the collection manager, but were not supposed to be available to end users. Those were still mapped to an internal notes field that we have in digital collections. And that's only there for repository admins and collection managers to see. And the next step was to create the context and the admin set for the collection, as well as creating a role to administer access. And the role was given manager permissions to both the admin set and the collection. And while this was happening, we also had to retrieve an export of the metadata from the legacy system, which was a very, very large metadata set. And then that had to be checked and cleaned to aid in easier migration. And then after that, we had to retrieve the images from tape storage to generate the new derivative files that we needed for the IIIF-enabled viewing in digital collections. This was a time and space consuming process since the collection had over 39,000 associated image files. And we ended up requesting the help of our system admin to retrieve the files from tape storage, so we weren't needing to make calls for large batches ourselves to tape storage or constant calls to tape storage to keep up with all the importing that we needed to do. So the files were a combination of TIFF and JPEG files with different naming patterns and lengths, so there was some processing workflows that we had to figure out that way. And due to this complexity, Suda ended up creating a new image processing script just for this, to be able to handle these variations, as well as to skip the preservation step, as these files were already preserved in tape storage, so we didn't have to put them back up there. The files were then processed in small batches, and the resulting pyramidal TIFF derivative files were grouped into folders to enable easy file selection during ingest. And the final step was to ingest all of this into digital collections, but it was actually not that easy since we had to begin with taking the clean metadata and using a Python script, transform that into the fields that digital collections is expecting. So that was a step. Our student employee worked on that. And that involved extrapolating fields, which had the codes or drop-down values in the legacy system that we had to make sure we were capturing and showing correctly. This transformed metadata was then used to create an ingest CSV spreadsheet, which also had to pay attention to the associated image files, which were not really clear from the export. So some works had multiple images on them, but they weren't groupable by file name. And we have a little example that we can show you coming up here. I had to go into the legacy system and compare the files listed on those legacy objects to correctly group the multiple files that went together on a single work. So once those file lists were established, they were added to the CSV spreadsheet, and then this ingest spreadsheet was then broken up into smaller batches that matched the groupings of files that we did for the derivative, the pyramidal TIFF derivatives, and we were able to chunk that up in the previous step for ingest into digital collections. Next slide, please. So what we have here, this is a side-by-side look at the collection landing page for the Jerry Slocum Mechanical Puzzle Collection. On the left is Image Collections Online, the legacy system, and on the right is IU Digital Collections collection landing page for this collection. And next slide, please. Thank you. And then here is a side-by-side look at a work record in each system. And this particular screenshot is showing an example of an item with multiple files where not all the files had an identifiable connection to the work. So we had an identifier on the work that matched one file for this image, but the other file, completely different file naming there were reasons for it, but it wasn't anything that we were able to correctly associate and track, and we had to do some work to try and figure out all of those files that went together on a single work in many cases. So there was some things involved in that. And now I will pass it back to Sudha to talk about outcomes from this migration and the lessons learned.
Thanks, Julie. We successfully migrated a total of 37,184 works for this collection. And now that migration has been completed, the collection management is now undertaken by the collection curator. To aid them with clarity in the metadata fields for new content, we created an ingest cheat sheet that described how fields from the old system were combined in the new system, as well as providing them with possible internal labels they could use to provide more clarity for their patrons. In addition, an ingest template was also provided to help them populate metadata records for bulk ingest. We also set up a whole new file processing script to check the files for file naming and preservation standards. The script also generates derivatives and pushes the original file to tape storage for preservation. We do not want to be confronted in the future with more mismatched file names. Lessons learned. From this and other migrations we have completed so far, we've learned to expect messiness. We also prioritize the collection and make the best effort possible to preserve its richness while ensuring future usability. And the most important thing about this whole process was the importance of taking mental breaks and practicing self-care to avoid burnout. We're still learning about that. Thank you, everybody, and we're happy to answer any questions you might have.